Hello, my lovely students. You're welcome to a new lesson. Today, I shall be teaching you mensuration, and we shall be looking at solid shapes. By the end of this lesson, you should be able to solve problems involving the surface area, the volume, and capacity of solid shapes. Happy viewing. Hello, my lovely students. You're welcome to a new lesson. Today, I shall be teaching you mensuration, and we shall be looking at solid shapes. From definition, mensuration is the process of measuring and or calculating lengths, areas, and volumes of geometrical shapes. Also from definition, solid shapes are three-dimensional shapes in nature, especially with a considerable height. That is, they have length, breadth or width, and height. Some examples of solid shapes include a cuboid, cube, cylinder, prism, cone, pyramid, sphere, and hemisphere. Let's learn more about solid shapes. Let's learn about the surface area and volume of solid shapes. The surface area of a solid shape is a measure of the area of its outer surface. Surface area is measured in square units such as centimeter squared or meter squared. Some examples of the surface area of a solid shape include: number 1, the curved surface area or the lateral surface area. Number 2, the plane surface area or the flat surface area. While number 3 is the total surface area of a solid shape. Also from definition, the volume of a solid shape is a measure of the space it occupies. Volume is measured in cubic units such as centimeter cube or meter cube. Let's see the formulas for the surface area and the volume of various solid shapes. Number 1, we have the cuboid. The formula for the total surface area of a cuboid is 2 times length times breadth plus 2 times the length times the height plus 2 times the breadth times the height. Factorizing with 2, the total surface area of a cuboid is 2 into length times breadth plus length times height plus breadth times height, while the volume of a cuboid is length times breadth times height. For a cube, the total surface area of a cube is 6 times the length squared, while the volume of a cube is the length raised to power 3. For a cylinder, the curved surface area of a cylinder is 2 pi radius height. The surface area of an open cylinder is pi radius squared plus 2 pi radius height, which we factorize into pi radius into radius plus 2 height. The total surface area of a closed cylinder is 2 pi radius squared plus 2 pi radius height, which we factorize into 2 pi radius bracket radius plus the height. while the volume of a cylinder is pi radius squared height. For a prism, the total surface area of a prism is 2 times the base area plus the perimeter of the base times the height, while the volume of a prism is the base area times the height. For a cone, the curved surface area of a cone, pi radius times the slant height. The total surface area of a cone is pi radius squared plus pi rl, which we factorize into pi r bracket the radius plus the slant height. Don't forget, the slant height can be gotten from Pythagoras formula, which is the square root of the square of the perpendicular height plus the square of the radius. While for the volume of a cone, the volume of a cone is 1/3 pi radius squared height. For a pyramid, the total surface area of a square base pyramid is the base area plus the area of 4 triangular faces. That will give us a squared plus 2al, where L represents the slant height, which can be gotten from Pythagoras formula, which is the square root of a squared plus a squared divided by 4. The volume of a square base pyramid is 1/3 times a squared times the perpendicular height. A here represents the size of the base of the pyramid. For a sphere, the total surface area of a sphere is 4 pi radius squared, while the volume of a sphere is 4/3 pi radius cubed. For a hemisphere, the curved surface area of a hemisphere is 2 pi radius squared. The total surface area of a hemisphere is 3 pi radius squared, while the volume of a hemisphere is 2/3 pi radius cubed. Please take note of all these formulas because we are going to need them in solving our examples for today. The capacity of a solid shape is a measure of the space inside it. Capacity is measured in the basic unit of the liter. Liquids are usually measured in liters. The relationship between the volume of a solid in centimeter cube, meter cube, and decimeter cube and its capacity in liters is as follows. Number 1, 1000 centimeter cube is equal to 1 liter. Number 2, 1 centimeter cube is equal to 1 milliliter, which is equal to 0.001 liter. Number 3, 1 meter cube is equal to 1000 liters. While number 4, 1 decimeter cube is equal to 1 liter. Please take note of these relationships. Moving on, let's see our first example on surface area of solid shapes. Question 1. Calculate the total surface area of the following solids. Question A, we have a cuboid. Question B, we have a cylinder. Now, can you remember the formula for the total surface area of a cuboid and a cylinder? Let's see if you can still remember. For question 1A, the total surface area of a cuboid is 2 into length times breadth plus length times the height plus the breadth times the height. In the diagram, the length is 8 centimeters, the breadth is 5 centimeters, while the height is 3 centimeters. Substituting these values into your formula for total surface area, you are going to have the total surface area of the cuboid in question 1a being 158 centimeter square. 158 centimeter square. For question 1b, the total surface area of the cylinder is 2 pi radius squared plus 2 pi radius height, which we factorize into 2 pi radius bracket radius plus the height. In the question, pi is 22/7. The question gave the diameter as 14 centimeters. So to get the radius, divide 14 centimeters by 2. That will give you a radius of 7 centimeters in question 1b. The height of the cylinder is 4 centimeters. Substituting these values into your formula for total surface area of the cylinder, your answer becomes 484 centimeters squared. 484 centimeter squared. I hope question 1 is clear to you. Moving on to our second question for volume of solid shapes. Calculate the volume of the following solids. In question A, we have a cube, while in question B, we have a cone. Once again, can you remember the formula for the volume of a cube and a cone? Let's see if you can still remember. The volume of a cube is the length raised to power 3. In question 2a, the length of the cube is 12 centimeters. So the volume is 12 centimeters raised to power 3. That will give a volume of 1728 centimeter cube. In question 2b, the volume of a cone is 1/3 pi radius squared height. Pi is 22/7. The radius of the base circle in the cone is 14 centimeters, while the perpendicular height is 6 centimeters. Substituting these values into your formula for the volume of a cone and solving, you are going to get the volume of the cone as 1232 centimeter cube. 1232 centimeter cube. I hope question 2 is clear to you. Let's take our last question for capacity of solid shapes. Example 3. A rectangular tank is 76 centimeters long, 50 centimeters wide, and 40 centimeters high. How many liters of water can it hold? From the solution, the volume of a rectangular tank, which is a cuboid, is length times breadth times height. The length being 76 centimeters, the breadth 50 centimeters, and the height 40 centimeters. Multiplying these values, the volume of the rectangular tank is 152,000 centimeter cube. But the question asked, how many liters of water can the rectangular tank hold? So the relationship in converting centimeter cube here to liters is 1000 cm cube is equal to 1 liter. So if this is the relationship, the capacity of the rectangular tank is going to be 152,000 divided by 1,000 liters. That will give us 152 liters. So the answer to the question in example 3, the tank can hold 152 liters of water. I hope question 3 is clear to you. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic mensuration solid shapes, continue to read your textbook. Don't forget to attempt your quiz and your assignments. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.